Okay, so last week we talked about how each circuit has to have 4 major parts. It needs to have a power source. It needs to have some type of load, which could either be a resistor, it could be a light bulb, which you could also draw like this, or it could be a motor. There's lots of different things that it could be. Then you need to have a wire, and you need to have a switch. So those are our 4 main components. And what we did was we put our 4 main components into one simple circuit. So our simple circuit looks like this. Oops, I drew that as a closed. That's okay. Our circuit's going to be closed right now. So that's our switch. Accidentally drew it closed, guys. Trying to draw over top of the camera here. That is your most simple basic circuit, and it's going to work because our switch here is closed. So our resistor will have circuit or current flowing through it. Now, this would be the most simple circuit you can do. There are also 2 other kinds of circuits. So you've got series and parallel. Now, how people talk about series and parallel normally would be like Christmas lights. Christmas lights used to be the most annoying thing in the world because they were in series. So if one light went out, all of the lights went out. So these are in one loop. And if one goes out, all go out. So they're not super efficient. And then you'd have to go through your string of 100 Christmas lights and figure out which one wasn't working. Parallel, on the other hand, has many, oops, spelled many wrong. See, again, I can't do this over top. Many loops, many paths. And if one goes out, they don't all go out. So that's the main part here. So we're going to draw some different types of systems here. So it's different types of circuits. So I'm just going to get a better pen. So if we want to do series to start, so series means all one loop. So what does that look like? So I'm going to draw my battery. And battery often has more than one cell. So they often draw it with more than one set together. And that's fine. So we're going to have our electrons come out here. And we're going to have a light bulb here. We're going to have a light bulb here. And we're going to have another light bulb here. Then we'll have a switch and we'll be good. So I'll just draw a circle around because you need a circle around all of these to make them correct. So here is a series. Your electrons, your little electrons are going to exit out here, go this way, come around here, go around here, come around here, and go back into our battery system there, which means that they really only have one path and they have to go through each one of these light bulbs, which is why if one of the light bulbs goes out, all of the other light bulbs go out. They essentially become like a switch. So that is your basic series. So parallel, on the other hand, parallel means that we're going to make multiple loops. So how does that work? So we're going to take our battery exactly like we did before. And the reason why I'm drawing these for you is because sometimes I find that they're easier to build if you know what they're supposed to look like in the end. So you should be able to take this and actually create a circuit from it. So you're going to come around here with your wire and you're going to hook up one light bulb. And then you're going to essentially come all the way back. And we're not going to even put a switch on this one. So here is our one light bulb. That's our one path. That's our basic circuit like we did before. Then what we're going to do is we're going to add another light bulb, but we're going to give it another path to follow. And we're going to draw our circle around. And because we did 3 on the last one, we're going to do 3 on this one. We're going to give it another path over here to follow. So here is our parallel circuit. So we're going to draw 3 different electrons. So electron number 1 is going to come out here. It's going to come up to this transition point, and it's going to decide to go here. Now, electrons are like humans. They're going to take, the majority of them are going to take the easiest way possible. So if these light bulbs don't have different resistances, then it will be equal number of electrons going through each one. So we're going to come this way, and they're going to come back into the battery that way. But another electron could come out and it could be like, no, I don't feel like going that direction. I could come this way and I could come back here. So that's our second path. So far we have 2 different paths. Our third electron, I really should have planned my drawing better. Third electron could come all the way up and go through this path. This is why if I took out this light bulb, these 2 would still be lit because the electrons have a complete path going through both of these light bulbs. And this one is just a third path. I could take out the middle one, I could take out the first one, and you would still have a complete path for the other 2 sets of electrons to go. Parallel, much easier to keep things on. So if we go back to the series here, if we take one of these out, the whole circuit is broken, everything goes out. So the last thing I want to do is talk about our, ammeter, and our voltmeter. So our ammeter measures our current, and this is the amount of electrons per second. Our voltmeter measures the potential difference and it's going to be measured in volts. This is also the energy given to the electrons. Oops, can't see that. Energy given to the electrons. This current, this is measured in amps. So this on your circuit is just an A in a circle, and your voltmeter is just a V in a circle. And so what's important though is this is always, look at, I'm just having like the spelling day. It's so good that I'm doing this in front of all of you. Always joined in series. Always. This one is always joined in parallel. Now there is a reason for this, and it's what's inside, and you'd actually fry or break the internal components if you put this one in parallel or this one in series. And so without getting too much into why and how all of that works, that's physics 30. But just knowing that that's how they work, you just need to remember how to join them. So you don't have these at home, so it's not like you're gonna break one, or I don't think you have them at home. So if you've just got your basic circuit, you're gonna have your ammeter in series to your resistor, and your voltmeter goes in parallel on the outside. And that is really the most important thing for you guys to get today. So hopefully that makes sense, and we'll see you next time.